Very first part of finding limit is the beginning of the calculus. So let's consider a function. F of x is 3x plus 5. We'd like to know what happened as x goes 1. Suppose we select a input number x that is closer to number 1, and we are looking for output number of a given function, 3x plus 5. So the number x approaches to 1, which is closer to 1. There are two ways to be considered. X can be close to 1, but slightly smaller than 1. X can be close to 1, that is slightly bigger than 1. So X can be approximated 0.999999 in one way, or X can be approximated 1.000001. And we could add extra decimals that could make the number closer and closer to 1, approach to 1. So suppose we have this function, f of x is 3x plus 5. This is a straightforward linear function. We are able to graph this function. So let's graph this function. When x equal to 0, y equal to 5. When y equal to 0, x equal to negative 5/3. So let's graph this. So this is the graph of function. And we point 5 here and negative 5/3 here as xy intercept. The question is, when x is closer to 1, what happened the function 3x plus 5? So we want to see the behavior of the function when x is approximated to 1. The important part of this question, x is not equal to 1, it's closer to 1. So the first number, I pick 0.9999. So x is closer to number 0.9999. The number is slightly left side of this one. So number closer to this. When x equal to exactly 1, as you see, when x equal to 1, then we have 8. But it's closer to 1, then we know this number is not exact 8, but it's closer to 7.99999, and keep on going this way. On the other hand, if it's closer to 1 but slightly bigger than 1, so I'm looking at the point right here, then your function is closer to this point. That is 8.00001. And eventually, when you add extra decimals of these two numbers, and these numbers are closer to 1. So we can say when x is approximated to 1, we know 3x plus 5 approaches to 8. And we write this into mathematical notation. That is what we call the limit. So limit, okay, we take this two letters out, LIM, we read this as limit x approaches to 1, x is close to 1, what happened to your function? That is equal to 8. That's how we write it. But in fact, this is a linear function. Linear function is continuous function. So if function is continuous, then this is exactly same as limit x approaches to 1 of 3x plus 5. That is, we just substitute x equal to 1. Okay, then we can just have 8. That's exactly same as this, but not always happened. Let's try example. Example 1 on bottom of page 7. We want to know what is behavior when x approaches to 2 of a given function, 3x squared plus 2x minus 1. So your given function f of x, that is 3x squared plus 2x minus 1. This is a quadratic function. Quadratic function is continuous. So limit x approaches to 2 of 3x squared plus 2x minus 1. We just substitute x equal to 2, 2 squared plus 2 times 2 minus 1. We combine this together. It's 12 plus 4 minus 1, which is 7. So the limit is 7. Let's try another example. So this time we have a rational function. F of x is x cubed minus 1. Okay, x cubed minus 1 over x minus 1. Okay, so something similar what we had before. Let's try. So the question says what happened when function approaches to 1. So this is a question of a limit x approaches to 1 of a given function f of x, that is limit x approaches to 1 x cubed minus 1 over x minus 1, which is 1 cubed minus 1 over 1 minus 1. Our usual routine of solving this is 0 over 0. We are in trouble. Okay, so any fraction with the denominator 0 is undefined form. Not only that, this gets worse. It's because its numerator is 0, denominator is also 0. This is undefined form. In an undefined form, this is not always undefined. It's case by case. Sometimes we do have exact number. So we want to use exact same technique that we had before the first example. What we want to do, we want to consider the function's value x approaches to 1. So do you remember when x approaches to 1, we consider two things. The number is close to 1 but slightly bigger than 1. Number is close to 1 but slightly smaller than 1. Left and right. So here is 1, and I'm looking for a number close to 1, slightly bigger than 1. So I can think as number like 1.1 and 1.01, 1.001, and so on. And on the other hand, the number slightly smaller than 1 but closer to 1, 0.999, and I am adding extra zeros there. Okay, so as you see, we have two columns here. So one is 4, number close to 1 but slightly bigger than 1, and the other column is number close to 1 but slightly smaller than 1. So we use calculator for this case to calculate it out. So I substitute 1.1. So 1.1 cubed minus 1 over 1.1 minus 1. Use a calculator. We have 3.31. Same thing, 1.01 cubed minus 1 over 1.01 minus 1. Then we have 3.0301. And keep on doing this way. You have extra 0. You have additional 0. Okay, so I have extra zeros here, like that. Same thing, 0.9. So 0.9 cubed minus 1 over 0.9 minus 1. We have 2.71. And then you add the extra decimals. You add the extra decimals. 7001. 2.9997001. And now you see one side of column has number slightly bigger than 3, another side of column that is slightly smaller than 3. They are very close, and you add the extra decimals, and we know these two numbers agree to closer to number 3. So what we consider this limit, and we conclude limit x approaches to 1 of x cubed minus 1 over x minus 1, we write it as a 3. Now, we can write it, but when we actual example like this, do we always have to make a table? The answer is no. What if we don't have calculator? How do we compute for this particular problem or something similar to this particular problem? We are using one technique here. This is what we called algebraic limit. So the first thing we have to do, that is factoring. Okay, so once you have this form, 0 over 0, and we want to conclude a limit is equal to 3. So the first thing we want to do is factoring. Okay, so once you have this guy, you put the start mark in here. Original function f of x, that is x cubed minus 1. And the key point of doing this is factoring. Okay, so x cubed minus 1 over x minus 1. We factor the numerator, x minus 1, x squared plus x plus 1, all this divided by x minus 1. Now, in algebra, we know we can cancel this numerator denominator if x minus 1 is not equal to 0 or x is not equal to 1. Okay, this is okay. The reason is we are taking a limit x approaches to 1. This means, okay, x is closer to 1, but x is not equal to 1. Okay, so two different things. Okay, it's close to 1, not equal to 1. So this takes care of it. Okay, so we have limit x approaches to 1 of x cubed minus 1 over x. That can be written as limit x approaches to 1 of x squared plus x plus 1. We substitute our usual routine. This is a quadratic, so that's 3. This is exactly what we plan to find from the table. All right, go to the next page. There are a couple of examples. So please pause and try this example. Okay, so I'm back. For the last 5 minutes, you try this, and let's go over this together. So this is equal to, okay, 2 plus 3 over 2 plus 6. We first substitute x in the limit of this. That is 5. 8, the whole number. No problem. The limit is 5/8. It's straightforward. Okay. Another few minutes. Pause. Do it together. Okay, I'm back. So limit x approaches to 1, x squared plus x minus 2 over x squared minus 1. Again, let's check. So we put x equal to 1. Okay, so this is a case 0 over 0. Okay, so we do need a factoring. Okay, so let's do factoring. X squared plus x minus 2, they can be factored as x minus 1, x plus 2. We have x squared minus 1 in the denominator. They can be factored as x plus 1 and x minus 1. All right, it's a factorable. So x squared plus x minus 2 over x squared minus 1 can be written as x minus 1, x plus 2 over x plus 1, x minus 1, x not equal to 1. So x plus 2 over x plus 1. So we can simplify this fraction. So limit x approaches to 1 of x squared plus x minus 2 over x squared minus 1 can be rewritten. X approaches to 1, x plus 2 over x plus 1. That can be rewritten. X approaches to 1 as 3/2. Yes, limit exists. The limit is 3/2. So next page, we are writing full explanation of how to find the limit of f of x equal to 2x plus 3. I leave you this page. You can just read over. There's one thing we have to be careful, that is the definition of a limit. So we want to state the limit definition. definition is a function f has the limit as x approaches 2 from either side. So this is the question, what it means either side, number slightly bigger than 1, number slightly smaller than 1. That's what it meant. Limit x approaches to a of f of x equal to finite number L. Then we said limit is L. So all values of x, f is closer to L when x is arbitrarily close to a but not equal to a. So this part is important. Close to but not equal to. Okay, there's another example in next page. Again, we can take factoring. Okay, we can take a factoring and we can find the limit. All right, and another example in page fully explained, so you can just read over. Instead, let's try problem 3 here. Okay, again, pause the screen 5 minutes after, and we try this together. Okay, so we first check the limit x approaches to 2. Two x squared minus 5x plus 2 over 5x squared minus 7x minus 6. We substitute 2. 2 times 2 squared, 5 times 2 plus 2 over 5 times 2 squared minus 7 times 2 minus 6. This is a 0 over 0 case. Okay, so we have to do something, which is a factoring. This is the only technique that we have learned. So this is, we write it, limit x approaches to 2. Let's look at the numerator. Are these factorable? So 2x, okay, and x, because 2x squared. And we have 2 and 1. Let's see, negative, negative. First term, outer term, inner term, last term works okay. 5x, and then x, and we have a 2 and a 3. Let's see, negative, and then this is positive. So first term, outer term, inner term, last term. Very good. X minus 2, they are taken care of. Limit x approaches to 2. 2x minus 1 over 5x plus 3. We substitute x equal to 2. That is a 3 over 13. So we get the solution, 313. So this is one way we can do with the factoring. Let me show you one more technique of how to find the factoring. Now the question is, the quadratic like this or quadratic like this, it's hard to factoring, and some of us have a hard time to factoring. So like this type of question, instead of factoring, we want to do something different way. Okay, so since x approaches to 2, we want to rewrite it. Let h goes to 0. Okay, we want to rewrite it, and what we want to say, x be 2 plus h, writing this way. So h is equal to x minus 2. X minus 2 goes 0 because x approaches to 0. So then we write it. Okay, then we write it. Limit h goes to 0, and we substitute x equal to 2 plus h. 2 times, 2 plus h squared. 5 times 2 plus h plus 2. All this divided by 5 times 2 plus h squared minus 7 times 2 plus h minus 6. Okay, and that is limit h goes to 0. Okay, and we factor this. Okay, let's do FOIL. So we FOILed and simplified. We have a numerator and denominator. There is a common factor, h. So let's factor that out, h. So 2h plus 3 over h and 5h plus 13. Then h and h canceled, so we have a limit h goes to 0 of 2h plus 3 over 5h plus 13. H is 0, 3, 13th. Exact same answer as we do. So this is the second way of solving this problem if you are unable to factor it.